Hello friends, I am Khalid Mehraj Malik. I am an electrical engineering graduate from Jammu University, Jammu and Kashmir, and I am here for you people to discuss syllabus, competitive examination syllabus of electrical engineering, and I have decided to discuss this syllabus with you, and we shall be doing this in a collaborative way, and I hope that we shall go good in this cause, and I look forward to be with you people till I reach the success rates of my lectures, of my videos. So I hope that all of you are acquainted with the basic terms of electrical engineering, like what is a resistor, what is a capacitor, what is an inductor, what is a current, what is a voltage, and basic laws such as KCL, KVL, Kirchhoff's current law, Kirchhoff's voltage law, and considering that all of you are well acquainted with those things, so let me start with the very basic chapter of electrical engineering. We study in the third semester or whatsoever, as per your university, as per your college. DC basics and networks. From here our electrical engineering starts off towards the higher level subjects. So we shall be starting with our lecture today with network analysis and synthesis. So starting off with it, friends, we are going to discuss DC basics and networks. Friends, a subject that comes under this very portion is network analysis. So we shall start with that. Network analysis. Since we are preparing for a competitive examination here, we are not going that too academically as we study in our colleges or universities. We study everything in very detail. So here we are going to focus upon only those parameters that are very frequently asked in examinations, and we shall be going not to in a short way, but in a very emphasizing way that will emphasize upon the very basic points that are very much required in the competitive examinations. So let us start with a circuit here. I shall make a circuit like this. I put an inductor here with a voltage source. Okay, friends. Here I put a resistor . Here again I put an inductor, again a resistor, and I tie it up with a ground here like this. Again let me put another branch here. Suppose there is a capacitor in it. Okay, friends. So, considering this very topic today, let me do one thing. I'll change this central branch and put it here so that I may make a complete node from complete junction. From here, I'll be taking 1, 2, and 3 branches. Wiping this out, I'll make it over here, and I'll make another resistor here so that the structure will be very coherent and very clear for you people to understand what I am going to do here forth. here I make an inductor. So friends, you can see I have an inductor here, two resistances here, one another resistance here, and a capacitor over there on the top. So what I am going to do basically, I'll try to make a graph, a reduced form of this circuit. What is the reduced form or what is a graph? Let us understand. What we have to do, we have to short circuit those very parameters, whether it be a voltage source, whether it be an inductor, whether it be a capacitor, or it be a resistor. We will short circuit those sources and only keep the links between the nodes. So let us make a graph of this. This will reduce like this. One important thing that we have to note here is that the voltage, that is the potential level that is located here on the bottom branch is same for those 1, 2 and 3 points. Okay, so we can tie up all those 3 points into a single common point. Okay, let us do this. Eradicating those parameters, let us make it. It will be like something like this. We will combine all the 3 points on the bottom into a single point. 1, okay, and this one. Then comes this point, this branch, it comes like this, okay, and then after this point we have this point going to this point, then again from this point you will go to this point, and this point again meets the bottom branch and it will touch here. Okay. What about the top branch? It will connect this point and this point. Like this. So what do we see here? We have nodes, node A, node B, node C, node D, and node E. We have how many nodes? 1, 2, 3, 4, 5 nodes. Okay friends, so we have to remind a rule, we have to recall a rule that there cannot be more than one connections between two consecutive nodes. So what we have to do here, if we see point B and point D, there is one connection that connects point B to E and there is another connection that connects point D to point E. So we cannot connect B, C to D. So we have to make this one into a dashed line so that there is no direct connection from B to D. Over again, B is connecting to D up by the upper branch. So we have to make it also into the dotted form. It becomes like this. Moreover, you can see point B connects to point E and point A connects to point E. So point A connects to point B, point A connects to point B, point B connects to point E, and point A connects to point E. It indicates there that there are two links. So what we have to do, we have to make this into dotted form also. For instance, I am citing this as an example for you people. Okay, so what do we see here? We see how many solid branches are there? 1, 2, 3, 4. 4 solid branches. And how many dotted branches? 1, 2, and 3. So friends, solid branches form a tree. Let us name them 1, 2, 3, 4, 5, 6 and 7. we have numbered the corners, we have numbered the nodes, nodes by A, B, C, D and E, and we are numbering the branches by the numbers 1, 2, 3, 4, 5, 6 and 7. Okay, solid branches form a tree, and how many branches? They are called twigs. Branches of a tree, they are called twigs. So what are the twigs here? The twigs here are 1, 4, 3 and 7. How many twigs? Number of twigs is equal to 4. Dotted branches form a co-tree. Friends, say solid branches form a tree, then what will the dotted branches form? They will form a co-tree. And how many branches are there in a co-tree? Let us see. Branches of co-tree are called links. What are they called? They are called links. So how many links are there? Let us see. Links are, let us name them 2, 5 and 6. 2, 5 and 6. Again recalling why we have made some branches dotted and some branches solid, for the only reason that there cannot be two solid branches between two consecutive nodes. There can exist only one. Okay, so the links are 2, 5 and 6. So number of links is equal to 1, 2 and 3. So we have 3 links. How many twigs? 4. How many links? 3. Okay friends, so what are the extra things that we have to recall from this is that this very thing is called the reduced form of an original circuit, or it is called a graph. We can reduce this graph into a matrix form. The matrices and determinants that we study in our mathematics, and we shall be applying the rules of that very thing from mathematics accordingly. So we will try to reduce this graph into a matrix. So first of all, studying complete incidence matrix. That is denoted by AC. So friends, what we have to do now, we have to make this graph into a matrix form, into a mathematical matrix form. So setting up the rules for that, say n is equal to nodes. What are n? N are the nodes. B are the branches. So the elements of the matrix will be formed by elements of matrix. AC will be formed by A, N, B. Each element of this complete incidence matrix that we form from this graph will be A and B, where N is the number of nodes and B is the number of branches. So let us try to make this AC here. AC will be like this. Here down we see our nodes. What are the nodes? A, B, C, D and E. We will write them A, B, C, D and E. And what are our branches? 1, 2, 3, 4, 5, 6 and 7. So writing the rules here. Entering -1, exit +1, not incident, 0. What does that mean? Suppose some branch is entering into a particular node, then we will mark -1 against that very thing. If some branch is exiting, going out from a particular node, we will write +1. And if some branch has no link with any particular node, then the entry will be going 0. Okay. Let us see the node A and corresponding branch 1. Node A and branch 1, what it is doing? It is entering into this node A. Branch 1 is entering into node A. So what will we write? Entering -1, corresponding to this and this, -1. So what about the branch 2? Branch 2 and node A and branch 2. Branch 2 is exiting from this. So we will write +1. Branch 3, 4, 5, 6, 7, they have no link with node A, so we will mark zeros. And accordingly we will be filling AC. And what will be its order? What will be the order of matrix? Rows into columns. How many rows are there? There are 7 rows. 7 into how many columns are there? Columns are as much as the number of nodes. A, B, C, D, E means 5. 7 into 5. So AC has order N into B. And rank of AC is always rank of AC is always n-1, nodes -1. Or we can say by derivation process, if we were to study academics, we would reach to the conclusion that rank of AC is n-1 or nt. So noting up to here, this is complete incidence matrix. So again we have to do one more thing. We can reduce this complete incidence matrix into an incident matrix over again by eradicating the word complete. How we will do that? We will eradicate one row. How many rows are there? A, B, C, D, E, as much as the number of nodes. We will eradicate one row and make it an incident matrix A, only A. So let us suppose we eradicate the row named E. That will form a new matrix. Which will be called incident matrix A. Okay, noting up to here. please note down this much so that we may wipe out the board and go to the further. So friends, I hope you all have noted this much. So let us wipe this out now. What we shall be doing, we shall be forming a new matrix called incident matrix. A. Recall that previously we had done a matrix with the mark AC, but here this matrix is with the mark A only. So what we shall do, we shall eradicate one row. AC was like this: A, B, C, D, E, and 1, 2, 3, 4, 5, 6, 7. So we shall be deleting this row. Delete. How many rows will be there now? 1, 2, 3, 4. 4 rows and columns as much as they were there originally. Okay, this will form a new matrix called incident matrix A. So recall, AC was of the form n into B. What will be A now? A will be n minus 1 into B, or n minus 1 is equal to number of nodes into number of twigs. I already told you that it will be a part of derivation process, which we are not going to do here, by which we can be concluding that n minus 1 is equal to nt. So writing it directly here, nt into B. The rank will be n minus 1. Rank of A will be n minus 1, which is similar to the rank of, which is same as the rank of a tree. Rank of a tree, that is n minus 1. A tree also has the rank n minus 1. Moreover, we can reduce this A into form. A can further be reduced into the form AT into AL. Recalling back, how many twigs were there? There were 4 twigs. How many links were there? 3 links. You can see in your graph. So we can do it as follows. A will be, how many twigs? 4 twigs. How many columns are there? There are 7 columns. We can divide it into 4 into 3. Sorry, 4 and 3. 1, 2, 3, 4, 5, 6, and 7. And similarly, A, B, C, D, only D, not E here, because E was included into AC. So this matrix will form this matrix will form a T, and this matrix will form a N. Okay friends, so if we see, this one will be a square matrix because it has 4 rows and 4 columns. So what is it? It is a 4 into 4 matrix. Here we see. So we can write it in the form of square matrix n minus 1 into n minus 1. So what is the order of AT? AT has the order n minus 1 into n minus 1 because it is square matrix. What is the order of this one? Order of this one, order of AL. It will be B minus n plus 1 into B. B minus n plus 1 into B. Sorry, T, tweaks. So what is the order of AL? L corresponds to the links and T corresponds to the twigs. So new matrix, incident matrix, is divided into a matrix of twigs and a matrix of links. The matrix of twigs is a square matrix and has order n minus 1 into n minus 1, and the matrix that is formed by links will be of the order b minus n plus 1 into p. Is that all? Yes. Determinant of A, the value of a matrix is given by its determinant. So the determinant of this incident matrix will always be 1. And one more point to remember, the determinant of complete incident matrix that we earlier studied will be equal to 0 always. So that was the basic theory regarding network analysis and synthesis of today's lecture. So further part that you have to do is that you have to open some competitive examination book regarding electrical engineering and solve as much as problems that could be over there regarding complete incident matrix and other forms. Okay, as much as problems you solve, you will gain more firm control upon it. Okay, concluding our lecture today, we shall be coming with the upcoming lectures as well. I am looking forward to be with you people till the completion of our syllabus. So be with me, subscribe my channel, share my channel and like my videos if you feel the material that I fetched to you people is worth appreciation. Okay, thank you.